Hello everyone and welcome to our educational presentation. My name is Paul Arsuf and I'm the founder of Decentralized Web Project. The topic of our educational event today is slicing the world into discrete entities, vision processing for AI. And this continuation, this part 2 of the presentation, which started last week. And we're going to start with the case of two people. And these two people, like we have to wonder whether they're the same person or these are twin brothers. And so if we talk about vision processing, errors are going to give us a clue. Even though with any distinction we may make errors, we can still designate in the main that there are two people and not one. When we are wrong, such as when we punish the wrong twin for the acts of his brother, we can realize it and correct ourselves. Of course, we may still be making an error. What if the twin actually lied? As mentioned, the fact that we can correctly distinguish between twins is important in cases where clear logical reasoning must be performed. A teacher of twins would have to separate them when planning a field trip to know how many people, how many pairs of children should be enrolled on the bus and how many must return with it. The math is discrete, no vagueness is permitted. And that last word, permitted, gives us a clue as how to resolve the riddle. The reason our mind distinguishes otherwise identical twins always comes back to the fact that not distinguish them creates problem for us. If the difference didn't matter, we would have no reason to make a distinction. Consider, for example, a web browser running on your computer, which on certain day updates to a completely different version, but which appears and functions largely as before. By default, your mind will continue to respond to similar experiences in similar ways. You would not care that the browser was swapped with its twin, nor identify it as different, because the change causes you no problems. Any distinction will always be on the basis of whether it is necessary, and necessary implies that it is relative to an immediate motive. We would only start to conceive of the new software version as a different entity when it causes us issues the old one did not, or actually resolves issues which the old one had. And we want either to revert back to the old version or praise the new one. There must always be a motivated person, even if the reason is a simple desire to be pedantic. And the same is true of the twins. Treating two separate humans as a single person based on appearances will lead to problems. There are cases, however, in which no distinction between the twins needs to be made. If they share a taste in clothes, their mother may purchase clothing for both while treating them as a single unit. Similarly, Cole's bully may call the twins by the same name without any twinge of concern. Finally, a person unaware that they were twins will only recognize the fact when it causes him confusion or embarrassment. The need to distinguish them by finding some discriminating input only arises if there is a problem uh, context that drives it. Nothing in the stream of inputs itself can trigger the distinction for you. In some cases, minute differences may be carefully taken into account. In others, enormous differences can be safely ignored. The question always remains: does one person care? Of course, the stream of experiences itself still matters. Otherwise, your thought and actions would have no purchase on reality. So it is, for example, that on seeing the same person at two different times, your mind will automatically trigger similar thoughts, which you have previously learned for an input. And even so, for twins, your response will, in most cases, reflexively unify the two as the same person. That is, you respond to their similar appearances with similar thoughts and actions. However, there's more to a response than just this first reflex. There may be subsequent effortful acts of interpretation that happen for each new experiences with the twins. When we need to call a missing twin to come down for breakfast, we may have to make some efforts to determine which of the two is present right now. Your first instinct is not always sufficient. In contrast to calling other acquaintances for whom this decision would be straightforward, the desire to call the twins' name will trigger a special tension learned from past slips-ups. To take actually extra precautions. The mind now looks for some confirming input or thought which either allows it to select the first name that comes to mind or infer the alternative. This will be a new learning at that moment. The tension must first attach the correct name to the experience of the twin correctly present. Then subsequently use that new connected thought to logically infer the name of the one absent one. For example, Kevin is the first one and the other one is Kent. This process is conscious, meaning that it leaves a lasting memory, the attached thought of the event. Since the connection you make is based on what you are trying to achieve, the success of your endeavor always determines which interpretation, whether Kevin or Kent, ends up being attached. When dealing with identical twins, any number of options are available. If only one twin is present, you may decide to call him and his brother by the same nickname to avoid slipping up. Uh, this Thus, the interpretive thought, the intention of what to say, will be driven by the pursued utility. Underscoring the above analysis is a hidden implication, namely that there are no stable mental entities or concepts anywhere in the mind allocated for each of the two people. Distinction and designations are made in the moment as part of the flow of responding to immediate experiences by transferring past learning into new instance. Recognition is always a momentary action. By default, our minds treats the twins, at least by appearance, as a common entity. The only distinction we make between them is in response to the immediate need arising in our thoughts, such as what name to give the one we are looking at, or which extracurricular lessons to drive the twin currently um, in our car, for example. If you already learned to identify Kevin by a mole on his hand or his mispronunciation of Adaji, then on hearing him say that word again, you need to make the effort anew. The thought will already be there in response to the inputs, like a math calculation. We don't need to carry out a second time once we have figured out the answer. Uh, if no immediate thought is present, or if a doubt arises about the validity of our initial thoughts, our mind must put some heuristics to the task to discover an interpretation that gives greater confidence. That is ultimately what a doubt is. Either way, such a concept of the twin does not extend beyond these momentary thoughts into deeper mental structures. The popular the popular belief in mental entities or concepts which remain stable beyond the immediate specific thoughts that pass through our mind is perhaps the single greatest error in the field of cognitive psychology. Once accepted, it leads innumerable confusions, paradoxes, um, and irreconcilable contradictions. The discrete separation of entities, when it is performed, happens only in the concrete space of the senses, not some abstraction dimension of concepts. Uh, so what is proverbial so-called epistemological knife? How do we cut the flow of experiences so that we have correct vision processing? Since, as shown above, discreteness is determined by momentary practical tension resolution, it is responsible to inform uh, that the tension and resolution themselves must therefore be discretely defined. This is in fact the case. Sensations may be continuous, but the experience of attention and its resolution happens in discrete moments of time. This is the last piece of the puzzle which connects the act of moment to moment learning to the flow of experiences. Treating tension resolution as time delimited is perhaps an uncommon perspective in AI research. Although reinforcement learning platforms regression at distinct moments based on rewards in order to resolve the question of this presentation, we must push discreteness uh, to its limit. Whether or not we solved a math problem or believed we solved it must be either true or false at a given time. Logic can only be built on discrete foundations. When viewed in the aggregate, such responses may seem probabilistic. If we give the same math problem to many people, we may get a distribution of answers. But that does not mean that a given person's answer is also a distribution. An individual's action response is discrete, and so is the underlying decision. What remains is to tie together the timing of what gets learned to the tension resolution cycle. Going back to the twins, when trying to determine what to call the individual in front of us, we are triggered by a momentary need, tension. We don't know what name to say aloud. This happens right before we speak as a cautionary response learned from previously confusing their names. Our mind now looks for indicators that hint as who the one before us may actually be. The article of clothing, name tag, anything that based on previous experiences triggers the interpretive thought containing their name. This now gets elicited and immediately captured as a solution to the current tension. The auditory thought of the name is locked in as a new learning, a novel thought response to the immediate appearances of the person standing in front of us. Although this is shorthand description, its purpose is to show how minor on and off triggers of tensions and resolutions create the discreteness of our responses. The earliest segregation of units occurs in time, not in space. There is a span of time between experiencing tension and experiencing its resolution, where everything in between may be captured as part of the correct response. This is the first epistemological knife. Any special separation uh, defining the outlines of the object arises out of the temporal one. The same tension, as it is resolved multiple times, can select out of the mass of sensory inputs, both in thought and in external experience. That subset that recurs as part of the solution. It discards the rest as noise, which helps generalize the response outside the immediate specific circumstances. Background noises and extraneous sites are removed, leaving only what is essential. This process comprises the unification half of the uh, dilemma here. On the other hand, if a resolution is not achieved in any previously learned way, then instead of pruning away what is extraneous, additional inputs are included by which our mind discriminates the current experience as a special one. This is the other half of the dilemma discrimination. Both unification and discrimination are automatic processes. They occur before we are consciously aware of them. The goal ultimately of this approach is to make the process of problem solving concrete and practical for AI implementations. We're no longer relying on vague notions like object or need to define the problems a mind may be faced with, but rather we base them on specific inputs and the particular timing of their appearance. We are also removing the need for inductive biases of hard-coded prior knowledge and allowing the system to learn to separate entities autonomously based only on its own stream of experiences. Move from narrow to general. This allows us to turn a continuous space of inputs into a discrete mental objects and events sufficient for performing logic. The key, however, is to base these discrete entities not on abstract concepts, but on the immediate process of transferring between concrete sensory thoughts. We must reformulate abstraction and generalization into a dynamic cycle that migrates what was learned for one concrete experience to another one. The symbol X is in mathematical logic is no longer an abstract variable, but rather the actual appearance of the character X in thought and in reality. Once we make this assumption, we find we can unite problem solving, object recognition, concept manipulation, and generalization transference into a single harmonious model. And with this set, I'm ending this presentation. I like to come back to the beginning of this presentation when I told you that my name is Paul Arsov and I'm the founder of the Decentralized Web project. We're building a decentralized communication and advertising platform, and we did release also a marketplace and collection of NFTs. So what is interesting, special and unique about these NFTs is that they're based on three-dimensional objects. What is unique, special about this three-dimensional object is that we have our own 3D software engine, which what it does is it reads the file of the 3D NFT, it opens a window on a computer screen, and it loads the 3D NFT, and it starts animating it in a way of moving it in a random fashion around the window. with with this set, I the 3D software engine has multiple additional capabilities, and the first capability of our 3D software engine is the capability of speaking. Our 3D NFTs can speak in one of three different voices. The 3D NFTs can speak either in a male voice or in a female voice or in a whisper kind of a voice. In addition to the three basic voices, there are flavors of voices. A voice can be spoken either in a normal speed manner or in a fast speed manner or in a slow speed manner. And so if we take, for example, a male voice and it is spoken in a slow speed manner, then this voice can come as the voice of an old person or the voice of a very masculine person. So if on the other hand we take a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a little girl or the voice of a funny person. Uh, the next additional and important capability of our 3D NFTs is the capability of voice recognition. The 3D NFTs can recognize commands, and for example, if we have a 3D NFT in window and it moves in a random fashion, that we can issue our very first voice command to this 3D NFT to stop moving. And the 3D NFT, which has been moving in a random fashion, is going to stand still and stop moving and being animated. We can then issue following voice commands, like for example, move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these voice commands. The next additional and important capability for our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply with who they are. Um, you can ask the 3D NFT to describe something, for example, describe Web3 or describe decentralization or describe Russia. And then the 3D NFT is going to reply in few sentences about Web3 or about decentralization or about the country called Russia. With the last but not least important capability of our 3D NFTs is the capability of them being projected in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and part of the 3D NFT is going to be displayed in blue or bluish colors. Then you can come to our website, and probably this is the name. The time I can tell you the name of our 3D NFT marketplace. It is 3dnft.decentralizedweb.org. 3D NFTs typed in a way of the number 3 followed by the letter D followed by three other letters NFT. and it is all together 3D NFT. Then there is dot, then there are two words, decentralized and web, and they're all together, decentralized web. Then there is dot, and it ends with org. Once again, 3dnft dot decentralizedweb.org. With on the top of the main page and every other page, you are going to see a link to accessories, and when you click on this link, you're going to see that we offer special glasses. You can order one pair of these glasses, and when you receive these glasses, you're going to see that one lens of these glasses is red and the other lens is blue. Then you can put these glasses on. You can request displaying of the 3D NFT in a way of stereoscopics, and you're going to see that the 3D NFT is coming out of the flat two-dimensional computer screen, and you can see it in 3 dimensions. So this is the last but not least important capability, and I like to tell you a little bit about our marketplace as well. In our marketplace, we have our own blockchain instance. It runs Ethereum software, and it is the same software which runs on Ethereum mainnet, on Binance Smart Chain, on Polygon Matic, on Avalanche Avax, and many other blockchains. With by running our own blockchain instance, that we do not require our users to pay gas fees for the transactions and of deploying the smart contracts for the non-fungible tokens, and transactions of transfer from one user to another user. And so by having our own blockchain and running it, we do not require our users to have just a single purchase this 3D NFT in a single crypto coin, but we currently offer payments for purchase of the 3D NFTs and receiving proceedings from sale from 4 popular crypto coins. The choices include Solana Sol, Polygon Matic, Avalanche Avax, and KuCoin, which is a big centralized crypto exchange. It has a coin called KCS. In addition to buying and receiving proceedings from selling crypto, we have second, parallel, and independent way of buying and receiving proceedings from sale, and it is done directly in fiat currency. I can give an example. For example, if you're user and you come to our 3D NFT marketplace, you click on the composite image of our first collection of 3D NFTs, and then you are going to see all of the 3D NFTs in our first collection showed on the page. Then you can browse and you see one 3D NFT that you like. You click on the image of this 3D NFT, and then you're going to see a page where there is a short video of the 3D NFT moving, and then there is like a drop down menu where you can select to pay between 4 different crypto coins, and the fifth choice of paying with fiat currency. Let's say you select paying with fiat currency. you click on the button to advance next, and what is going to happen is your payment in fiat currency is going to be converted from your national fiat currency to US dollars, and it is going to be deposited in our bank account. Uh, so what is going to happen then is a second action, and we are going to transfer the initial ownership from our 3D NFT marketplace to you, and you become currently the first user of this 3D NFT. So let's say you decide you are playing with this 3D NFT for a while, and at some point you decide to put this 3D NFT for sale. You decide on the price that you want to put, and then the 3D NFT is going to be listed for sale on our marketplace. So let's say there is a second user, they come to our 3D NFT marketplace, they browse through the 3D NFTs, and they like in particular the 3D NFT that you put for sale. So let's say the second user goes through the choices of paying with crypto or paying with fiat. They select paying with fiat currency. So what is going to happen then is they select payment with fiat currency, and their payment is going to be converted from their national fiat currency, which could be different than your national fiat currency, and different than US dollar, and it is deposited in our bank account. So what is going to happen then is we are going to be following this action with a second action, and transfer of ownership from you, the current user, to the second user, and now the second user becomes the owner of this 3D NFT. Then we are going to be having a third action, and the deposited in our bank account payment, we are going to send it to you. We are going to be converting it in your national fiat currency, and you're going to receive it in your bank account. And with this set, I'm going to end this little introduction of our 3D NFT project, and I like to tell you a little bit about another project that we have been working on. And this project is about power management and electric vehicles. If we look at the current growth in numbers of electric vehicles, they're going to reach at some point exponential growth because of the mandate of by 2035 to have to sell only electric vehicles, and not vehicles based on internal combustion engines. And with this mandate and exponential growth of electric vehicles, there is going to be a problem in charging of these electric vehicles. So what we are proposing is we're building a number of products which is going to be deployed at specific points. And so what are these specific points? Currently, the charging of electric vehicles is based on a so-called gas station model, And in gas stations, internal combustion engines, they go to uh, column, and they put the they load fuel in their vehicle, and they pay, and then they leave. The charging of electric vehicles follows this model, where there are specific locations where there are several columns, and owners of electric vehicles, they can connect the charging cable to their vehicle, wait a certain amount of time to charge their vehicle, and they pay for the charge, and then they leave. With this model, we anticipate that the number of these specific locations based on the gas station model are going to become very insufficient. So what we are proposing is the parking lot model, where the chargers are placed at the point of like if a person lives in a high-rise building, then they have a parking lot where there are multiple vehicles parked, and usually in the evening or during the night, the car is staying out there, and it could be charged, connected to electric power, and charged at the time of arriving of the vehicle for the evening, and then it could be disconnected in the morning, and the person leaves the building. With Um, with this set, so this is one of the specific locations where the people can charge their vehicle at the place of living, and the place of their homes. But people are working, and sometimes or often they work in like high-rise office buildings, and these high-rise office buildings, they have parking lots as well. With in these specific locations, they could also, when they come to work in the parking lot of this office building, they can connect charging cable to their car, and between 9 o'clock when they arrive, and 5 o'clock, for example, when they leave, they could be charging their vehicle as well. With this set, so the types of products that we're working on and developing, they include a switch of electric power. They include a controller. They include near field communication reader, so that the person can identify themselves to the charger, and they could start charging with their credit card, debit card, or NFC near field communication token, which could be like a keychain token, or it could be like a card, or it could be even a ring which a person is wearing. And I like to tell you the name and the URL of the website of this project that we're working on. It is power.rstack.com. Power is the usual word for power, then there is dot, then I can spell the letters of hashtag it's Alpha Robert Sam Tom Echo Charlie Hotel. Hashtag then there's dot and it ends with com. And with this set, I am ending this presentation. Thank you for watching, thank you for viewing. Have a nice day, have a nice evening, and goodbye.